How will mmWave evolve in 5G Advanced?
Thank you, Captain. So mmWave continues to be a key component of 5G with expanded features in 5G Advanced. These features will enable robust new use cases as well as deployments, define new network components, and enable better utilization of mmWave spectrum. On the network side, we have new components like network control of repeaters, as well as VMR, or mobile integrated access backhaul. Both these technologies will enable better, cost-effective, robust mmWave deployments. We're also further improving robustness for applications such as VR, with improvements like L1, L2 mobility enhancements, which will allow for quicker, less disruptive handover between transmit points. We also want to enable new spectrum sharing paradigm that will allow better utilization of some bands, while still guaranteeing a certain level of QoS for certain applications. I see these new sharing paradigms play an important role as we go up higher and higher in bands, especially towards sub-terahertz.
Can you talk to me a little bit about the role of AI in 5G mmWave and how it will improve user experience?
So AI ML in mmWave systems is something that we've been evaluating, showcasing for a number of years, and will be studied in 3GPP in release 18. Some aspects are not necessarily specific to mmWave, but will benefit across all bands. And other aspects like beam management on the network or device side will has a great potential to enable more robust and power efficient mmWave systems. We've shown the performance of both GNOB and UEB management improvements, which translate into better performance, greater coverage, as well as reduced signaling overhead. There's also a role in AI in mmWave network design and for deployments. We've showcased how AI-enabled map-based tool can evaluate terrains like different cities, come up with optimal deployments, cost-effective deployments, utilizing small cells and repeaters, automatically taking into account foliage, buildings, other blockers, and come up with candidate sites like streetlights. So we see AI will play a strong role in many aspects of mmWave systems as well as network design.
Apart from data communication, what else can mmWave bring to the table?
So the wide bandwidth, narrow beams or high directionality, and the limited interference can enable a lot more than just data-centric use cases. In fact, we've already taken advantage of these characteristics for positioning. We've been able to show centimeter level accuracy in our positioning demos. This is especially important for industrial factory use case where high precision is important for automation. We've evaluated this indoors as well as outdoors in our OTA testbeds to showcase the benefits of mmWave services. As we look forward, we can also see in mmWave and sub-terahertz that we have a new paradigm of joint communication and sensing. These systems will go beyond just positioning, but will be able to detect device or modem-free objects in environments through UE and GNOB cooperative sensing. So these systems will now enable new use cases and enable better deployments by sensing dynamic and static objects for blockage or reflection. Improvements in positioning and sensing will be key topics for 5G Advanced and 6G.